Okay, so I'm continuing from where I left off in the previous video. So now we are going to do some calculations using Boyle's law. P1V1 equals P2V2. Again, this is assuming that the temperature and the amount, the number of moles, molecules, atoms, is being kept constant or the same. So, like I said, P1 and V1 will be your initial conditions, your initial pressure and volume. What is the pressure and volume that you are starting with? And then P2 and V2 will be the final pressure and volume after there has been some type of a change in the conditions. So essentially we're using this law to predict the final conditions, or it could also be used to predict what the initial conditions were. So when you are solving these problems, you will have 3 of the 4 variables here, and then you'll be solving for one of those variables. One of the things that's really important is you have to make sure all of your units are the same when you plug into the equation so that they would cancel out appropriately. All right, in this first question here, it says a sample of oxygen gas has a volume of 150 milliliters when it's at a pressure of 0.947 atm. So those are the starting conditions. So what I would recommend when first approaching these problems is just write out what all of your variables are equal to. So our initial pressure is 0.947 atm, and our initial volume is 150 milliliters. Question continues, what will the volume be of the gas, so in liters? So that's what we're trying to find. So we are going to be solving for V2 in liters. So you could say it's question mark, or we'll say X. When our P2 has changed, so we've seen an increase in the P2, 0.987 atm. Based on what you've already learned, if the pressure increased, that means the volume is going to do the opposite, which is decrease, because this is an inverse relationship. So whatever you get for your X here, it should be less than this. However, again, like I said, you have to pay attention to your units. The final answer needs to be in liters, but right now my volume is in milliliters. Now you can do this, the conversion from 150 milliliters, we can convert that into liters. So we would move 1, 2, 3 decimal places to the left. This would be 0.15 liters. You can do this before you plug into the equation, or you can do it after you've gotten your answer. I prefer to convert my units into what they're supposed to be in for the final answer before I plug into the equation, just so I don't forget to do that step. For the pressure, they are already in the same units, atm, so we're good there. So visually, this is what it will look like when you plug it into the equation. So we have P1, 0.947 atm, times V1, which I already converted into liters, equals P2, 0.987 atm, times X. So X is going to be our V2 that we're solving for. So you can leave it as X if you like for a variable. You could leave it as V2 if you want to have it as that variable too. That would be fine. I'm going to leave it as X. So now I'm going to do my math to try to get X by itself. So the first thing I'm going to do is I'm going to multiply 0.947 times 0.15. So that'd be 0.14 205. And right now this is ATM liters because those units have combined, equals 0.987 ATM. Then we have our X. So now I'm going to divide both sides by 0.987 ATM so that I can get X by itself. So again, this is why writing your units can be helpful, because if we have ATM over ATM, that cancels. So then my final answer is in liters, which is what I wanted. So now to solve for X, I'm going to take that value, 0.14205, divided by 0.987. So I'm going to go 4 significant figures. So my X is 0.1439. And the key thing is it's in liters, which makes sense because this is less than what we started with, which was 0.15 liters. So that also makes sense that this is the correct answer. All right, let's do another problem. All right. A balloon is filled with helium gas and it has a volume of 500 milliliters at a pressure of 1 ATM. So that looks like those are my starting conditions. So my P1 is 1 ATM and my V1 is 500 milliliters. Just be careful when you're reading these questions because sometimes I'm reading ahead a little bit. Sometimes I might give you maybe the final conditions and maybe I'm asking for the initial conditions. It's okay if you end up switching them. You just want to make sure that you have the right conditions that are at a specific time, like in a situation, that those things are being paired together. So our pressure is 1 ATM, and then at that time, the volume is 500 milliliters. So those two go together. Question continues saying the balloon is released and reaches an altitude of 6.5 kilometers. That's not relevant because I don't care about the height. And then it continues where the balloon has a new volume. So we have a new volume. So our V2 this time is 1,000 milliliters. And it says if the temperature has remained the same, and we can also assume in the previous question it remained the same, and that the number of moles or amount of atoms or molecules remain the same as well. What is the pressure of the balloon at this height? So P2 is what we're solving for. And let's say for this pressure, I should have stated this, but I'll tell you. I want the answer in, I don't know, torr. Okay. So X torr is what we're looking for. So again, I'm going to plug into my equation. Now, my volumes are the same, so that's good. As long as they're the same, those units will cancel out. It's not like you have to convert them into both be in liters. That'd be silly. As long as they're the same, that's what matters. So they will cancel out when we plug them in. However, for my pressure, right now my pressure is in 1 ATM, but my final answer, I want it in torr. So let's say, all right, excuse me, let's just say for our final pressure, let's just say we want it in ATM. Just to make this a little bit easier for this example. All right, ATM. Let's say that's what I want the final answer in. Again, usually I'll tell you what I want the final answer in for pressure. So in this situation, I don't have to convert anything actually because my units of volume are the same. And then right now what I have for my pressure is an ATM, and that's what I want my answer in. So this is what it's going to look like when I plug everything in. So P1 is 1 ATM times V1, which is 500 milliliters, equals P2, which is X ATM. That's what we're solving for, times, or we'll just say x, excuse me, x and times 1,000 milliliters. So if I multiply these two together, that would be 500 ATM in milliliters equals 1,000 milliliters, and then we have our x. I'm going to divide each side by 1,000 to get the x by itself, 1,000 milliliters. So then that's how these units will cancel out. So I have 500 divided by 1,000, so my x is 0.5 ATM. And that actually makes a lot of sense proportionally because our volume doubled. And remember, this is an inverse and proportional relationship. So if my volume doubled, it makes sense that my pressure was cut in half and decreased by half, because that's the type of relationship that we have for Boyle's law. It's an inverse relationship, and it's also proportional.